We are down to our last 2 weeks of class. So we have this week and we have next week. So you guys have a final that's going to be due on the 18th at 11:59 p.m. You want to make sure that you get your final done by that time, because if you don't, the system shuts off. I won't be able to open it up. Nothing. So that is like the deadline to turn in anything. I will open up all your labs, all your homeworks till that time as well too. And then so once that time is up, I can't accept anything else. Okay. Later today, there will be signups for your presentations. So you and your group need to decide when you guys want to do your presentation and then sign up for the block of time. Okay. It's the days, it's going to be Monday evening when I have my lab normally. It'll be during this time period where you have your lab normally, and then it will be on Wednesday in the morning. And let's see. But part of next Wednesday, is also going to be a review in the morning for the final. So I'll be doing a review for the final on Wednesday morning. Not tomorrow, but next Wednesday. This Wednesday, the lecture has already been recorded. It was recorded yesterday, so that'll be posted. So there won't be a lecture. I have to go to a conference tomorrow, so I'll be out all morning tomorrow to go to this conference for training. So there won't be a lecture tomorrow. I will also send an email reminding you guys of that for those who didn't know. This is the last lab that you guys have to do. Are you guys excited?
I'm grinning.
You're grinning. I'm
Yeah.
sure they are too, but they're very quiet.
I'm
Okay.
grinning with them or for them.
Okay. Perfect. So this is your last lab. Um, I will have all your exams graded by the end of this weekend. So you will have a week to do your test corrections. Test corrections, again, you get half the points back that you've missed for the 2 exams that you guys have done. And I will do it for, like I said, only one of your exams, not both of your exams. And what else? There's something else.
Uh, Practice exam going up on soon, right?
Yes. So the practice exam will actually be sent out to you guys. Your practice final exam will actually be sent out to you. It's a PDF that you guys are going to be using for that. Okay. And so I'll be sending that out tonight as well too, later on tonight. So you guys will have that, and then you guys can study from there. If you guys have any questions, let me know. And we will actually be going over it, not this Wednesday, but next Wednesday. We'll be going over that practice exam.
And I don't know if you said this, but the final itself goes up on Sunday.
That's right. This Sunday at 11:59 p.m. it'll officially open. So you will have Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday to 11:59 p.m. to get it done. So you have at any point at that point to get it done.
Do not wait till Saturday.
Yeah.
One thing, Dr. Henry, that you said how you're opening all the assignments.
Yes.
So I think you're gonna have to like fiddle with the Labster demos
Okay.
because a student tried accessing one this morning, but they weren't able to like
Okay.
get access to them. So
Okay. So then I have to try to fix that. That's because officially our Lapster um, license expired in November, the beginning of this month,
okay.
officially. So I'm gonna have to talk to IT to fix that problem, to get them to put money in for for our license for it. So
Okay.
okay, well, well, with that, I will let you guys go. Are there any questions?
No questions.
No questions. Okay. Well, good
I
luck.
I have a question.
Okay.
Is the final gonna be on Canvas like the other two exams?
Yes, their final is going to be on Canvas like the other 2 exams.
Okay.
Yeah. Any other questions? Okay. Well, good luck. If you guys need anything, hit up my office hours. I also won't have office hours tomorrow, but I will have them on Thursday. And then there's always cocktail hours from 7 to 9 on Saturday. I will also, this weekend is Veterans Day. I will be there for cocktail hours, but I'll also be available in the morning from 8 to 10 in the morning. So I'll send an email about that too. So if you guys have any questions on homeworks or anything like that, okay? Okay, I will let you guys go. Good luck.
All right then.
I got on a little late. What did Dr. Henry say?
Uh, he went over important dates. To get you the Reader's Digest of that.
Yeah. I'll send an email out to remind you guys of those dates.
Okay.
Okay.
Okay, thank you.
All right. Let me share my screen. Can you guys see my screen?
Yeah, we can see your screen.
Okay. Last lab. Exciting. Today we're doing stoichiometry of precipitation reaction. There is an overnight component to this. So here during lab, currently, we're not going to be able to do that. That's something you're probably gonna have to do over on your own. But with that being said, let's get started. I don't think this lab is that long. I know it's 2 hours, but we'll see. Okay. Using the graduated cylinder, measure 25 mils of distilled water and add 25 mils of the water to 2 100 ml glass beakers. So let's start off with that. No mess so far. And then using the digital scale, we're going to measure 1.5 grams of calcium chloride. So make sure you tear the scale with the weigh boat on it. So it reads 0. And then we're going to try to get close to 1.5. Doesn't have to be exact. There is a small room of error allowed. Okay. I measured 1.54. So I could probably get a little closer to 1.5. So next steps is carefully add the calcium chloride dihydrate to one of the beakers that contains the 25 mils of water. Submerge the weigh boat into the beaker to transfer all of the solvent. If any residue remains in the weigh boat, swirl the beaker until the calcium chlorate is fully dissolved in water. So I have my calcium chloride in the beaker now. Now I'm swirling it. Okay. So step 8. Or if you submerge the weigh boat, you're gonna have to rinse it out with distilled water and dry it off. I was able to transfer everything without having to submerge it. But I think I'm still gonna rinse the weigh boat because we're probably gonna use it again here soon. But let's look at step 8 beforehand. So it says use the information and examples provided in the exploration to calculate how many moles of calcium chloride dihydrate are present in 1.50 grams of it. Then calculate how many moles of pure calcium chloride are present in 1.5 grams of the solvent. Putting my initials here. So where's my, okay, math time. So I have 1.50 or 1.54 grams of and we want to get this to moles. So let's start off by grabbing the molecular weight, this entire thing. By that, let's go to P table. So we know calcium has a molecular weight of 40.07 grams per mole. Chloride has 35. And we have two of them. And then hydrogen is, of course, 1 gram. And we have two of those. And oxygen is 16. But because we have two water molecules, we're going to multiply this by 2 as well. And that should get us our final number. So I got a molecular weight of 146. Did everyone get the same? All right. Now that we have the molecular weight, now we can go to moles. So our starting point is going to be, oops, 1.54 grams. And then we're using molecular weight that we just calculated over a mole, and grams cancel, and we're left with moles. We have 0.0 grams. So depending on how much you weighed in the beginning, it's gonna have a different value. But more or less the same. So let's add that. Oh, it's moles. Oops. All right. So now we're gonna do the same, but instead of the water molecules, we're simply finding the moles of the calcium chloride. So without the water molecules, we have a molecular weight of, I believe it's 110, around there. So same math process. That's that gives us right. Now we can move on. All right, I'm clearing the screen. It says using the information and examples provided in exploration and the values recorded, table 1, from step 8, to determine how many moles of sodium bicarbonate are necessary to reach stoichiometric quantities. From the calculation, determine how many grams of Na, or the sodium carbonate, are necessary to reach stoichiometric quantities, and record both values in table 1. So in a sense, we're kind of working backwards now. So let's find the molecular weight of sodium carbonate. So sodium is about 23 grams. Carbon is 12. And then oxygen is 16, but we have 3 of them. With a similar mass of about 106 grams per mole. So let's look at this balanced chemical equation. So we need moles of the carbon chloride to go to the moles of sodium carbonate. So because it's a 1-to-1 ratio here, in the previous table, this value, the moles of the pure calcium chloride is going to be the same for our sodium carbonate. Does that make sense? So let's use the value. Or we're using the first one, my bad. The 0.0105. Because that's how it is on the equation. So I'll write it up here. Is equal to the same amount of moles of our sodium carbonate. So we have 0.01. It's the same ratio. That's why they're the same. So since we know this, we can find grams. This is our starting point. And we use the molecular weight that we found earlier. So it's going to be a little different this time because we want moles to cancel. So moles go on the bottom and grams on top. Our moles cancel, and we have 2 multiply. We get about 1.11. So this is the amount of grams we want to measure of our sodium carbonate. So does everyone understand how I got this number? And again, it's probably going to be different for you guys because we all didn't measure 1.50 exact. So someone might have a slightly higher or slightly lower value. But let's fill out our table first. And let's measure. So if you rinse your weight boat, make sure you dry it with the paper towel. And then place the weigh boat on the scale so we can measure. Make sure it's that it reads 0. And I'm going to measure 1.11 grams. Okay. Now that that's measured, it says pour the sodium carbonate solution from the 100 ml glass beaker into the beaker containing. Oh wait, I skipped a step. Carefully add added to the 25 mils of distilled water in the second glass beaker. And then use a stir rod to break apart any clumps until it's fully dissolved into water. So make sure you're putting it on the second beaker, not the first one from earlier. Okay. While I'm still stirring, I'm gonna go ahead and keep reading. It says, okay, now we pour the solution into the first beaker that has our calcium chloride dihydrate, and then rinse the beaker that once had the sodium carbonate with 2 to 3 mils of distilled water, and then transfer that water into the calcium chloride, and then swirl the beaker until to fully mix the two solutions, and the precipitate of calcium carbonate will form instantly. Okay. Is everyone still following me so far? No one's confused yet? Okay. I'm now pouring the sodium carbonate into the calcium chloride. Now I'm going to measure about 3 mils of distilled water. Using the graduating cylinder from the first step. And then pouring that water into the empty beaker and swirling it around. Assuming this is to get every last bit of the sodium carbonate. And then I'm transferring it to the beaker containing both solutions. Okay. So I'm gonna clear my screen. All right. Number 14. Yes. Use the information and examples provided in exploration to determine a maximum theoretical amount of calcium carbonate in grams. So let's go back to P table. So we want calcium carbonate. So calcium, roughly 40 grams. Carbon is about 12. And then oxygen, of course, 16. Don't forget that we have 3 of them. Gives us a total of, where's my calculator? Darn. Pretty well. About 100 grams per mole. All right. We have the molecular weight. Now we have to determine a theoretical amount of grams that will be forming. And much like before, we're using that ratio of moles. So if we scroll up, we can see that once again, we have a 1-to-1 mole ratio. So because of this, we can still use that one number that we've got ages ago, the 0.0105 moles. So let's go ahead and solve this. That's a messed up 0. Okay. And then we want grams. So we're going to have it over 1 mole to cancel out. Okay, moles cancel, which gives us an answer of Well, for me, it's about 1.05 grams. So this is our theoretical amount of precipitant that we formed. If you look inside the beaker containing both solutions, you can see at the bottom that there's a solid formed. So in theory, that should be 1.015 grams for me. So let's keep going. Wash the now empty 100 ml beaker with soap and water and rinse the beaker with distilled water thoroughly and dry. Just gonna put on a new set of gloves because I'm paranoid. And then we can move on. So step 16, fold the round filter paper into a cone shape, as shown in figure 3. So my filter paper came out very beat up in the box. Hopefully your guys' has fared out a lot better than mine. It looks like we're just folding it in one half and folding it in half again. And then I don't know what the hell they're doing in that fourth step. So it looks like they're. Oh, okay. I get what they mean. Kinda. So if you keep one half closed and open up the second half, it makes a cone shape, which should fit perfectly on your funnel. Well, in theory. I think because mine is so beat up, it keeps wanting to bounce out. But I will have to make do. So I want us to record the mass of the filter paper. But before that, I'm gonna fill out more of this table here before I forget. I believe we should all have the same mass for the filter paper. I could be wrong. So place the folded filter paper into the funnel and dampen it with a small amount of distilled water. Swirl the contents of the beaker to dislodge any precipitant from the sides. So if anything formed on the side of your beaker, just make sure you swirl it so the solution can catch it. Keep it inside the liquid. Just, thankfully, mine didn't have any growing on the side, so. Slowly pour the contents of the beaker into the filled paper funnel. So I'm gonna go ahead and scroll up a little bit. One thing I am concerned about is it doesn't say to put the funnel on anything. Is the folded paper towel, the folded filter paper into a funnel, dampen it with a small amount of water, swirl the contents of the beaker to dislodge any precipitation. So, okay, here's how I'm gonna have mine set up. And so that beaker we cleaned earlier, here it is. Just give me 1 sec to make sure we don't have to use it again. Okay, it looks like we won't need to use it again. Good. So here's how I'm going to do it. I have the funnel inside the beaker. Like so. And then, of course, the filter paper on top. Like that. That's how I'm going to do it because I don't want any of the solution dropping out into like my table. Does that make sense to everyone? I hope. But before I pour in the solution, I'm gonna dampen my paper towel. Okay, filter looks dampened enough. All right. This is so scuffed, but that's a lot for you. So now I'm gonna slowly pour the solution over the filter paper. So this is the other solution. And I'm just gonna I'm gonna just pour it right on top, but slowly. There's a note here. Be careful not to overfill the funnel. It may be necessary to gently swirl the funnel to keep the precipitant from clogging the paper. But be careful to not touch the filter paper to not tear it. And then add 2 to 3 mils of distilled water to the beaker. Swirl the water around the sides to collect any solids stuck to the sides of the beaker, and then continue to pour it to the filter paper. Allow all the liquid to drain from the funnel into the beaker. So yeah, this is when it barely tells you to do that, which is insanity. Should have told you like 4 steps before. So I'm just going to continue to slowly pour the solution. And also make sure you're not doing so much or pouring so much, as you don't want the solution to overflow. Okay. So I'm going to keep pouring periodically since it's going pretty slow in terms of it dripping. So let's see. After all the liquid has drained from the funnel, carefully remove the filter paper from the funnel and place it on paper towels in a warm location. And it's November. That receives a lot of sunlight, so not my room, and where it will not be disturbed. Allow the filter paper to completely dry, which will require an overnight drying period. I didn't know the sun was out for night. Okay. So it looks like I almost got most of it poured. So when we're getting towards the bottom of the beaker, make sure, or if you're having trouble getting the last of the solid out, use like very little, like around 2 mils of distilled water. I believe it says that around here. Yeah, here, step 19. Use that water to help get the solids into the filter paper. So I would recommend try doing that within 1 or 2 tries, as you don't want to make your beaker overflow with distilled water over time. Okay, it looks like I got a little bit solid stuck on the side, so I'm gonna use distilled water to get the last bit down. Okay. So I got the last bit of it down into the beaker. While that drips down, I'm gonna go ahead and read ahead. If the end of the funnel gets like in the liquid solution, then just simply raise the funnel itself a little bit and give it room to let the liquid to pour out. Yeah, you might have to hold the funnel for like, I would say a maximum of like 2 to 3 minutes. So that being said, let's continue reading. So when the filter paper is dried, so for you guys tomorrow, tear the scale and place the paper onto the scale to obtain the mass, and record the mass on table 1. So it'll be this third to last box. And then calculate the actual mass of the precipitant. So the way you would do this is by, so let's call this step X. So our actual mass would be x minus the mass of the okay. Sorry, I'm just putting this funnel down. So I finished. Precipitant. Mass, yes. Okay, the actual mass of the solid, so Rx, minus the weight of the paper filter that we got initially. So 0.96. And that will give us our actual grams. And then next step it says calculate the percent yield of the precipitant. So do you guys remember how to get percent yield? Or the formula at least? So percent yield is actual over theoretical. Like, yeah, I know how to spell it. And then because it's a percent yield, we multiply it by 100. So we know our actual, and our theoretical is, well, the theoretical mass of calcium carbonate that we measured earlier. And then that will give us our answer. It'll be a percent. And that would go on table, well, the last table. And I believe that's, yeah, this is the only data sheet we need. So I'm gonna scroll down. It says dispose of chemicals properly and clean all equipment, thoroughly dry, and return them for future use. So let's go into our questions. So does everyone understand these last three steps? So pretty straightforward. So I hope no one's funnel paper ripped while getting it off the funnel. So mine is being set to dry right now. So let's move on to the questions. So question 1. Given that theoretical yield for isolating calcium carbonate in this experiment would be 100% in theory, from that information and based on your results obtained in this experiment, describe your success in the recovery of calcium carbonate. So how close were you guys to your theoretical? And then suggest 2 possible sources of error that would have caused you to not obtain 100% yield. So during this lab, could you think of 2 instances that might have brought up some error in your experimentation? I could probably think of one. I was not 100% exact in measuring So like earlier it wanted 1.50 grams. I measured 1.54. So that might have contributed. But maybe you got 1.50. And then what impact would adding twice as much sodium carbonate than required have on the quantity of product produced? Oops. So I got a initial of 1.1 grams. So if I were to double it, so 222, would that affect the overall reaction? And if so, how? Would my product, so the solid stuff formed in the solution, would that be affected? Next question. Question 3. Determine the quantity grams of pure calcium chloride and 7.5 grams of calcium chloride nonahydrate. Show your work. So this is exactly how we did the first couple questions. So up here, oops. Yes. So the process that we did for this section of the lab, you're doing it once again for questions 3 and 4. Although this time you're using different elements. And then question 5, conservation of mass was discussed in the background. Describe how conservation of mass, actual, not theoretical, could be checked in this experiment. So remember, conservation of mass, it's the theory of mass cannot be destroyed or created. So when we're doing the lab, we know that every chemical that we worked with, so let's go up here, had some play in the reaction that formed in that beaker. So we know we're not destroying or creating anything new. So I guess in a way, summarize that in your own words. And I believe, yes, that's it. So of course, evaluation's done on your own. And that's the lab, the final lab. Yeah. Those overnight sections have to be done on your own. I can't fast forward time. So I'm gonna just go ahead and go over a few announcements that Dr. Henry mentioned for the people that weren't here in the beginning. So practice exam for your final is going to be sent to you via email. It's a PDF file of the practice exam. And on, I believe, okay, Sunday the 12th, midnight, your final goes up. And you have until the 18th. Oops. You have until the 18th to do it. Dr. Henry is also putting up every assignment up and lab, so you can redo them. Or do them if you haven't, I mean. There is no lecture tomorrow. his lecture is already recorded. I will have that up as soon as possible. And next Wednesday, he will have a review session for the final. He will be going over the practice exam that he's sending you. And I forgot the time, but he will send you an email about it. And that's it. That's all I have for you. This is the last lab. So do you guys have any questions for me? If not, you guys are free to go. And don't forget to leave the filter paper to dry overnight.